A jigsaw puzzle is a picture divided into many small pieces. The pieces are mixed up, and the player put these scattered pieces back together to recreate the picture. Here, workers are paving footpaths with paving blocks in a way that's similar to how puzzles are put together. The gray and dark concrete pavements are changed to rectangular blocks of the same size but different colors. This makes our city more beautiful. Since the 1980s, the Highways Department has begun laying paving blocks on footpaths. Using paving blocks reduces the cost of repairs, as well as environmental and noise pollution caused by digging. It also enables creative landscape architects to make ordinary footpaths extraordinary with different patterns. We can form tessellations by putting two-dimensional shapes of the same shape and size together, according to a certain pattern without any gaps or overlapping. Which two-dimensional shapes can form tessellation? Learning by doing. Firstly, let's investigate whether triangles can tessellate a plane. Isosceles triangle, right-angled triangle, equilateral triangle, or any other kinds of triangle can tessellate a plane. Next, we'll investigate whether quadrilaterals can tessellate a plane. Of course square can. So can rectangle. The exterior wall and internal decorations of many buildings or even pavements are paved with square-shaped or rectangular-shaped materials, which are in the shapes of tessellation. Parallelogram can be used for tessellation. So can trapezium. Rhombus, and kite. Quadrilaterals, whatever the kind, can tessellate the plane. Besides triangle and quadrilateral, can regular pentagon tessellate a plane? When we try to put identical regular pentagons together, there are gaps in between them. That means regular pentagon cannot tessellate a plane. While regular pentagon cannot tessellate a plane, this kind of pentagon, which is a pair of equal and parallel sides and interior right angles, can. Now, let's come to regular hexagon. See? The answer is yes. The honeycomb is a well-known example of tessellation, which is made up of regular hexagons. And these hexagons can also tessellate a plane. What about regular heptagon? No, there are gaps in between. So regular hepticon cannot be used for tessellation. Neither can regular opticon. There are also gaps in between. We have seen that among the various types of regular polygons, only 3 of them, that are equilateral triangle, square, and regular hexagon, can be used for tessellation. What do these 3 regular polygons have in common that allow them to tessellate a plane, while other regular polygons don't? Since the regular polygons in a tessellation must fill the plane at each vertex, the interior angle must be an exact divisor of 360 degrees. This only works for the equilateral triangle, square, and regular hexagon. For all the other regular polygons, the interior angles are not exact divisor of 360 degrees, and therefore, these 2-dimensional shapes cannot tessellate a plane. Until now, we have been investigating the formation of tessellations with various polygons. We know that all triangles, quadrilaterals, a special kind of pentagon, and regular hexagons can tessellate a plane with no gaps or overlapping. Did you notice that the gaps created by the neat tiling of regular pentagons are rhombi of the same size and shape? That means that 2 or more different polygons can tessellate a plane. This pattern is tessellated with regular heptagons and squares. This one with equilateral triangles and square. And this with regular hexagons, equilateral triangles, and squares. Apart from using regular polygons, irregular polygons can also tessellate a plane. This pattern is tessellated with crosses. This one with arrows. And this with a capital letter F. We can also tessellate with shapes formed by curves. Just design the shape, make copies of it, and by rotation, reflection, and translation, make your very own pattern. Go exercise your creativity.